In this section, we are going to use what we learned in 4.1, 4.2, and 4.3 to solve problems which you may see in 2 dimensions, specifically solving triangles. To refresh your memory, remember that sine law for any triangle, let's say triangle A, B, C, is the following. It says that side AC divided by sine B is equal to side AB divided by sine C, which is equal to BC divided by sine A. Now, when you want to use the sine law, you always take two of these ratios, either these two, or these two, or this one and this one together, and you try to solve one of the unknowns. In the case that the unknown is angle, let's say we take these two ratios and we try to solve for angle B. So here we are going to say AC over sine B is AB over sine C. If you are using this ratio to solve for angle B, we are going to flip both fractions. We get sine B over AC is equal to sine C over AB. We just flip this fraction and this fraction, and if we cross multiply, we get sine B times AB is equal to AC times sine C. Divide both sides by AB. This AB crosses with this AB. From here we get sine B is equal to AC sine C over AB. Now we can use our calculator, and using the inverse sine we can find angle B, which is going to be between 0 and 90, which is going to be in quadrant 1. Some angle here. But if you remember from previous sections, since sine is positive, sine can be either in quadrant 1 or quadrant 2. This means that B can be either an angle between 0 and 90 or angle between 90 and 80. This is where we have to be careful, since our solution can have more than one answer. This is the case that we call ambiguous case. In ambiguous case, the problem has more than one solution, and you have to decide based on the context of the problem which one of those solutions are acceptable, or all of them are acceptable. So we are going through a couple of examples just to make this case a little bit more clear when dealing with real life problems. The first example, we have a triangle ABC with side in front of angle A to be 20, so this is 20. The side in front of angle C is 16, and angle A is 30 degrees. So we have the following situation. We are supposed to find number of distinct triangles that can be drawn using these measurements. Since we have two sides and angle in front of one of the sides, we can use sine law. So I can write that 20 over sine A, but A is given to be 30, so sine 30 is equal to C 16 over sine C. If I cross multiply these, I get 20 sine C is equal to 16 sine 30, or I get sine C is equal to 16 sine 30 over 20. Now, if we use the inverse function on the calculator, we get that C is approximately equal to about 24 degrees. Now, if we draw our angle, the reference angle, which is 24 degrees here, we know that sine is positive because the sign of this fraction is also positive. We know that sine is positive in the second quadrant, so our second possibility is this angle, which is going to be 180 minus 24, which is going to be 156 degrees. Now, we get two possibilities here. Either angle C is 24, angle A is 30 degrees, and angle B is 180 minus 24 minus 30, which is going to give us 126 degrees, which is possible. The other scenario is that instead of having angle C to be 24 degrees, we can have angle C to be 156, angle A is 30, and you can see automatically that the sum of these two angles is more than 180, so this is not possible. So this was the ambiguous case, an example that we had two solutions for C, 124, 156, and then we decided the only possible solution is C is 24. In the next example, we have a triangle ABC. So this is ABC. Side C, which is in front of vertex C, is 16. Angle A is 30. And side A in front of vertex A is 7. We are supposed to find how many distinct triangles can be drawn given these measurements. Since two sides and an angle in front of them is given, we can use the sine law. We can use 7 over sine of the angle in front of it, which is sine 30, is equal to 16 over sine C. If we cross multiply, we get 17 sine C is 16 sine 30. Now let's divide by 17. We get sine C is 16 sine 30 over 17, which is approximately 1.1428. Now, if you use your calculator, you will see that you get an error message because sine is never more than 1 or less than -1. Sine of any angle is between -1 and 1. And obviously this one is greater than 1. So this means that there is no triangle which you can draw with these measurements. A to be 7, C to be 16, and angle A to be 30 degrees. The next example, we have a triangle ABC again. So this is our triangle ABC. Angle A is 30 degrees, so this is 30. Side A, which is in front of vertex A, is 10, and side B, which is in front of vertex B, is 16. We are supposed to find the number of distinct triangles that can be drawn given these measurements. Again, we have two sides and an angle in front of them, so I can use the sine law. I can say 10 over sine 30 is equal to 16 over sine b. If you cross multiply, you get 10 sine b is equal to 16 sine 30. Divide both sides by 10, I get sine b is equal to 16 sine 30 over 10. This, if you simplify this one, this becomes 0.8. If you use the inverse on the calculator, we get that b is approximately 53.3, 0.13. Now again, this is our unit circle. This is 53.13. Sine is also positive in second quadrant. So the second angle is this angle here, from here to here, which is equal to 180 minus 53.13, which is going to be 126.7. Now, there are two possibilities. That angle A is given to be 30, angle B is 53.13, this one, and angle C is going to be 180 minus 30 minus 53.13, which is 96.87. That's one possibility, which is okay. The other possibility is angle C is 30, angle A is 30, but angle B is 126.7 now, this possibility. If you subtract the sum of 30 and 126.7 from 180, we get 23.3. And this is possible too. So in this case, we have two triangles. One triangle is given here with B 53.13 and C to be about 97 or 96.87. The other possibility is going to be a triangle like this one. C, B, A to be 30, B to be 127, about 127, 126.7, we round it to 127, and then the other one is 23.3. So two possibilities here. This is what we call the ambiguous case. The next example, we have the case of Jasperin, which needs a new rope for his flagpole, but is unsure about the length required. He measures a distance of 10 meters. So this is the flagpole. This is 10 meters, about is the distance from him from the base of the flagpole. From this point, the angle of elevation, which is this angle, remember, angle of elevation is the angle that your eyesight makes with the horizontal, to be 42 degrees. What is the height of the pole? Meaning this one, x. Since this is a right triangle, I can use the trig ratios. I have the angle, the adjacent, and I'm looking for opposite. So this is a good candidate for tan. So I can use tan 42 is equal to opposite, which is x, over adjacent, which is 10. Crisscross or cross multiply, we get x times 1 is x is equal to 10 times tan 42, which is approximately equal to 9. The second part of the question says, how much rope should Jasperin buy? This means I have to find the hypotenuse, let's call it y. Since I have x, the two sides, x and 10, then I can use Pythagorean theorem. I can say that y is square root of x squared, which is 9 squared, plus 10 squared. If we use the calculator, this approximately becomes 13.5 meters. In the next example, we have the case of Ishmeet, Helena, and Tanjot are standing on a soccer field. So let's draw the case which is given here. Let's say Helena is here, which represented with H. Ishmeet is here, which we represented with I, and Tanjot is here, which we represented with T. Now it says that the Helena, H, is 23 meters from tangent, which we are going to have this case. This is 23. From Helena's point of view, the others are separated by angle 72, so this angle is 72. From Ishmeet's point of view, the others are separated with 55 degrees angle, so this is 55. Now automatically, since the sum of the angles is 180 inside a triangle, we can say that this angle is 180 minus 55 minus 72, which is going to be 53 degrees. So this is 53. Now, this is the sketch of this problem, so part A. The question is, why is the triangle that is formed an oblique triangle? Because all three angles inside the triangle are less than 90, and the triangle has no right angle. This is an oblique triangle. The next question says, is it necessary to consider the ambiguous case? No, because the three angles are known. We do not need to use any sign law here. So no ambiguous case is necessary to be considered here. The last part of the question says, determine the distance from Ishmeet to tangent. The distance from Ishmeet to tangent, let's call this one to be x. This is the distance we are trying to find. Using the sine law, I can write that x over sine 72 is equal to 23 over sine 55. If I cross multiply, I get x sine 55 is equal to 23 sine 72. Divide both sides by sine 55. I get x is 23 sine 72 over sine 55. If we use the calculator, we get this is approximately 26.7. So this means that x is 26.7 meters, or this distance between Ishmeet to Tanjot is 26.7 meters. The next example, we have a lighthouse at point L, so this is the case. So we have a lighthouse at point L, which is 10 kilometers from the yacht at point Y. So this is 10 kilometers and 8 kilometers from a sailboat at point B. So let's call this one B. But we also know that from the yacht, which is Y, the lighthouse and the sailboat are separated by an angle of 48. So this is 48 degrees. Is it necessary to consider the ambiguous case? Now, this point, remember, we can move it to the left and we can get a case like this one. This is L, this is y, this is b, this is 48, this is 10, this is 8. Since this is a two-dimensional problem, and to solve the triangle we need to find all the angles, and to find all the angles we need to use the sine law, there is a possibility that there are two solutions as I have drawn here. If we call this one B1, B2, you can see that we can have two cases. One case is here, which B is less than 90 degrees, and one case is here where angle B is more than 90 degrees. So we have to consider both cases and to see which case is acceptable. Part B says sketch the possible diagrams for this situation, and these are the possible diagrams. This is diagram 1 and this is diagram 2. Now let's find the distance between the yacht, which is vertex Y, and the sailboat, which is vertex B. To find this distance, we are going to find the interior angles in this triangle. We can use the sine law and we can say that 8 divided by sine 48 is the same as 10 divided by sine B. If we cross multiply, we get 8 sine B is equal to 10 sine 48. Divide by 8, we get sine B is equal to 10 sine 48 divided by 8. If we use the inverse sign, we are going to get that sine B is equal to 68.3. Now, if you remember that in a unit circle, if this one is 68.3, sine is positive in the second quadrant too, so if we reflect this point on the y-axis, we get another point. So this is the next angle which is possible, which is 180 minus 68.3. So the other possibility is 180 minus 68.3, which is going to give us 111.7, which is this angle, which is the second possibility. So we have this case too. We call this one B2, this one B1, and this is L, and this is 10, this is 8. So now we have two possibilities. This is 68.3, so this is 68.3, and the other one is 111.7. Now what we have to do is to find YB1 or YB2. Let's call this one X1 and this one to be X2. So in the first case, which is this case, we are going to use the sine law again, and we are going to use the sine law to find X1 and in the second triangle X2. But in the first triangle, angle A is equal to 180 minus 48 minus 68.3, which is going to be 63.7. So our triangle, the interior angles are 48, 68.3, and 63.7. So we are going to write the sine law as x1 over sine 63.7 is equal to 10 divided by sine 68.3. If we cross multiply, x1 becomes 10 sine 63.7 divided by sine 68.3. If you simplify this one, we are going to get x1 is about 9.7 meters. So this becomes 9.7 meters. Now, if we use the same idea for the second possibility, which is this one, we are going to get L in this case is equal to 180 minus 48 minus 111.7 degrees. We are going to get this angle to be about 20.3 degrees. So the triangle, the interior angle in this case becomes 48, 111.7 and 20.3 degrees. Now we are going to use the same idea. We are going to use the sine law, and the sine law for this case we are going to use x2 over the sine of the angle in front of it, which is sine 20.3, is equal to 10 divided by sine of 111.7 degrees. If we cross multiply, we get that x2 is going to be equal to 10 sine 20.3 divided by sine 111.7 degrees, which is approximately, we get 3.68 meters. So this means that x2 in this case is 3.68 meters. So we have two possibilities. The distance between the yacht and the sailboat can be either 9.7 meters or it can be 3.68 meters. Another case of ambiguous answers. The last problem says that you have a radar screen at an air traffic control tower showing Air Canada 15 kilometers from the tower in a direction 30 degrees east of north. Let's draw this case. If this is our Cartesian coordinate system, x and y, let's assume that y, the positive y, represent the north direction. Positive x is the east direction, so this is east, this is north, this is west, and this is south. We know that Air Canada is 15 kilometers from the tower in a direction 30 degrees east of north. East of north is this direction, so Air Canada is here, so call it AC, Air Canada, and this is 30 degrees. Now the WestJet is 16 kilometers and in the direction of 10 degrees. So if this is WestJet, call it WJ, is 40 degrees east, which is this angle. This is 40 degrees. So the angle between them is going to be obviously 10 degrees. If the two aircraft are less than 2 kilometers apart, meaning that this distance is less than 2 kilometers, the controller must file a report. The part 1 says sketch a diagram, and this is the diagram that we have here. Label the distances and the angles. The next part says from the tower, what is the angle separating the aircraft? As we said here, the angle is going to be given by 10 degrees, which is shown here. The next part of the problem says, is it necessary to consider the ambiguous case? Explain, yes or no. Let's draw this case again here. This is 16, this is 15, this angle is 30, this angle is 10 here. Remember, this is a two-dimensional problem. We have to solve the triangle. To solve the triangle, one thing we have to find is this side. To find this side, I can use cosine law and I can find this side easily. So there is no ambiguous in this case. Now to find all the interior angles. Let's say I have to find this angle. If I want to find this angle, I know I have this side, I know I have this side, and I know I have this side, so I can use again cosine law. Remember, cosine law can be used without any ambiguous cases, because cosine, if we look at the unit circle, the cosine is positive here. The other possibility for cosine to be positive is going to be in the fourth quadrant. And in the fourth quadrant, the angle is greater than 270 and less than 360. So there is no possibility here that we can have two answers. So there is no ambiguous case if you're using cosine law. This means that I can solve this triangle without any ambiguous cases. So I do not need to consider any ambiguous case. Note. So the answer is no. Now the last part of the question says, will the controller need to file a report? Explain. In this case, what we have to find is the distance from this point, which is Air Canada, to this point, which is WestJet. Let's call this one x. I can use the cosine law and I can say x squared is 15 squared plus 16 squared minus 2 times 15 times 16 times the cos of the angle between them, which is 10. If we use the calculator and simplify this one, we get approximately this is equal to 8.3. So this means that x is equal to square root of 8.3, which is approximately 2.9 kilometers. Since the distance between them is 2.9 and this is greater than 2 kilometers, this means that the controller does not need to file a report.